Here we go. Review of special right triangles. Everybody's ready? Everyone has their AirPods? Everybody's good? Okay, so we take a look at problem 10, 11, and 12. We see we've got an x and a y. We have two different variables. We're gonna have to solve for them each separately. It's two different problems. So we take a look at number 10, and we don't have any angles. We know this is a right triangle, but we're gonna have to find the measure of the angles. What does that tell us we're going to be using? We are given, in a right triangle, the length of two sides. If we were asked to find the length of the third side, then we know that that'd be Pythagorean theorem. But they're not asking for the length of the third side. They're asking for the measure of an angle. So that should tell us something. Inverse, yes, I saw three of you guys doing inverse trig. Inverse trig, okay. So, we'll start with x. We have to find an angle to reference, right? So if we're referencing this angle x right here, we have to use the 5 and the 13. 5 is opposite, adjacent, or the hypotenuse? Opposite.
Wait, it has to be in. Why did you use the y angle?
I just decided to start with x.
Okay. Oh, I guess they're equal.
So, I mean, I could have started with y if I wanted to, but x is first, so start with the x. All right, so 5 is opposite, and 13 is definitely the hypotenuse, right? Because it's across the right angle. Which trig ratio uses opposite and hypotenuse?
Sine.
Okay,
Right.
so, bruh,
I'm gonna let you know. Oh my gosh. Shoot.
is booyah still in?
Absolutely.
Booyah?
You know what?
Booyah.
Yeah, it is.
So if you said sine, I could have been like, booyah.
Yeah.
Okay, so the inverse sine, so x, and we already went through y, equals the inverse sine of, and I'm running out of room, so I'll just erase this. Opposite over hypotenuse. We talked about y. Calculator, what do you get? Make sure the calculator is in degrees, right? We talked about if we use the green bar at the top, the high school version, that calculator's default. I'm just gonna show you. Hooray!
Shut up, Tommy. You don't know what it's like.
This is great. Hooray!
Hooray.
Hooray is a reference to, what was that game my kids used to play?
I know what you're talking
Dumb Ways to Die.
Oh, yeah. You
Hooray! Okay,
How about that?
so if we go to the toolbar, top right of the screen right here, this calculator is defaulted to measure angles in degrees, which is what we want.
Agreed.
Yes. If you just Google Desmos graphing calculator, you get the black bar at the top, which is fine. But that calculator's default for degrees, it measures degrees in radians, and you're gonna have to switch it. Okay, I prefer that you use this calculator. This is the calculator we use on our SOL. Just get used to using it. All right. Where are we at?
Tommy, in what ways would you
So, calculator. I got 22.62 degrees. It says to round to the nearest hundredth. So that's why I rounded to 22.62. Questions?
schools like equation?
Yes.
Other than school, that's what you just smart. So which one of those?
It didn't show up as 22.62. Let's do it.
How?
Inverse sine of 5 divided by 13. So I got, sorry? The x 0? Oh, that was degrees. So we're trying to find x is degrees, and then the degrees sign is right next to it. Okay, so let's go back. Where are we?
I don't think so.
let's start from the beginning, doing y, and then I'll stop this video. It's already at 5 minutes.
Break this
Okay, eyes up here. Referencing y, angle y. Okay, we're still using the 5 and 13. 5 is now going to be adjacent, 13 is the hypotenuse, right? So if we were going to set this up just using regular trigonometry, and I'll show you how we get the inverse trig. I just went straight to the inverse trig in the last problem, but maybe we need to take a look just from the beginning. The cosine of y degrees equals adjacent over hypotenuse, 5 over 13. Okay? So the reason we're using this inverse trig is because we have to undo this function because we need y by itself. Currently it's inside this function. So that's where the inverse comes from. I have no room to write it here. Good job, Cheryl. Let's try this again.
I forgot you're doing the show.
Because you don't tell teachers.
It's because you call me bruh. I'm just kidding. I just spaced it out a little bit better here. Now it's
Hey, come on.
there we go. Now that inverse cosine cancels the cosine and we have y isolated. And now we just plug this in the calculator and we get the measure of the angle. That's where the inverse trig comes from. So I don't know, I got 67.38. Now, look, if you get the measure, eyes up here, this is a right triangle. The sum of all 3 interior angles of any triangle is what? All 3 interior angles in any triangle adds up to 180. So if we just found, we know that angle is 90, this angle is 22 point and some stuff. We can just subtract those from 180 to get the measure of this other angle, but we're practicing trig, so that's why we put that in the calculator. All right, so.
22.62.